Good afternoon, everybody. Let me first thank Professor Jagtap for giving me an opportunity to stand here and talk to you, and also Mr. Saran. So, my topic is nuclear for clean energy transition, challenges and Indian industry preparedness. So I will be covering these topics one by one. So let me first start with the Vivekananda Foundation report, which talks about the requirement of power generation to meet the net zero carbon emission by 2070. That is what is the commitment, and that requires, apart from other figures, the maximum nuclear contribution is going to be about 250 gigawatts of power. And obviously the costs, etc., these are the figures which are readily available, so I will not much dwell upon this. So for our program, the government of India has already approved 21 gigawatts of power, and the 700 megawatts of PHWRs is going to be mainstay, which has been all recognized by everybody, and followed by 220 megawatts as a SMR, 1000 megawatts, 1650 EPRs. And this will possibly contribute to about 90% of 215. So about 180 gigawatts of power is going to come from these figures. Now SMR is another reactor which we are talking about. Since I have worked on this small reactors, so therefore I will little more focus on this subject. So these are primarily talked about for use in the coal-powered plants as a replacement, remote areas, etc. So this business is going to be, say, approximately 10%, which is about 18 gigawatts, which means about 180 SMRs of 100 megawatt electrical average capacity. So there will be some smaller reactors, but also 300 megawatt, 220 megawatts of PHWRs. These will be constituting this particular power supply. This business is quite big, and you can see about 800,000 crores of rupees Indian business. So obviously it is a very big business. Now, there seems to be a full agreement by all the agencies on serial B, that is indigenous component, with about 700 megawatts of PHWR as a mainstay. But there are differences of opinion for SMRs. Okay, these differences are not closing in. These differences are likely to hold up the good progress which we are making currently. So in the interest of the national commitment to the net zero carbon and a shortage of available time, because CO2 is not going to wait for anybody, so the ill effects of environment are already being seen, felt by the entire country, and therefore we need to minimize these differences and come on to the ground to solve this particular problem. So today, if you talk about SMRs, we do not have an executable SMR design. That's a fact. And we are talking about 220 megawatts of PHWRs, which is obviously a proven reactor, and we are all contributing to this particular reactor. But there are stakeholders, because everybody has to contribute to this SMR, and therefore I will talk about a little more about the stakeholders and their lookout to this particular business. So, concerns of the stakeholders, because we are as a company, because we have to respond to the stakeholders, we have to make profits, and we have to have an established proper business case. So we as an industry, we are looking at the stakeholders, but there are other stakeholders. So you can see the stakeholders: public, the end users of the power, Government of India, technologies for design, engineering, construction, operation, regulators, finances, industry, IAEA, insurance agencies, legal personnel, and material industry. So these are all stakeholders. And why we are talking about it? Because everybody can contribute to this, because such kind of program cannot be a single agency. There are multiple agencies, and multiple agencies have multiple interests. And unless today morning Mr. Ramani talked about the visibility. That visibility is very important for anybody who is contributing to this. And the visibility could be in the terms of materials, terms of design, terms of execution contracts and suppliers, legal and whatnot. And therefore, to being SMR under total control, we got to have proper visibility to the stakeholders. So what is the stakeholders they are looking for? First of all is the executable design. Indian or foreign design approved by our design agency and AARB is required. Unless that is available, the drawings are available for contract purposes, because there is no point in having a drawings which are on the design level, but the execution is different. You got to have proper tender documents and drawings suitable for tendering action. So we need to have this particular design, at least one or two, whatever the government finally decides. Materials and supply chain. Not many people have talked about supply chain, and unless we are talking about not 1, 2 reactors, we are talking about some 100 reactors. Now 100 reactors is a big business, and therefore chain of the supply has to be properly established. Then for each site, the design and construction stage wise, AERB approvals are required for each SMR, because each site may demand certain different characteristics, maybe seismic conditions, maybe water supplies are different. Sometimes you will get sea water, sometimes you will lake waters, river waters, or there will be no water, and therefore the air cooling systems will have to be incorporated. And so therefore each design will have to have this kind of changes and modifications required. So, and the site has to be approved by AARB. The fuel cycle requirements. So if we have a standard fuel cycle, and we want to have a closed fuel cycle, therefore entirety of each of the project, each of the design, that fuel cycle and the supply chain for the fuel supplies have to be assured, and more importantly also the waste management has to be in place. So this is important. Then to be firmed up is adherence to the Atomic Energy Act, because time and again in various conferences and various government communications, people are expecting the contribution from the public. Now today it is mostly the government funding, but if we have to have such a large kind of funding requirements, then we have to invite the public funding, and therefore, and that is not permissible under the existing laws, and therefore that is required. Then international laws we have to follow. IAEA inspection requirements, if any, we agree, then we have to follow. Proliferation issues and material safety. So these are the things we need to firm up. Then the liabilities of the suppliers. For the civil liabilities, insurance are required to be acceptable to the suppliers. Finance requirement, I talked about this. So there are also very important issues about the cash flow. So every tender which we are handling now, there are difficulties, but these difficulties are now getting minimized. So such kind of a cash flow requirement, public-private participation, foreign direct investment also is envisaged in some talks. It has come up, and so therefore Atomic Energy Act may be amended. Now affordability to the end user. This is very important, because you may generate a power, but if it is too expensive, then who will buy it? So we will have to ensure that the capital costs as well as the operating costs is well within the limits. And so assured business, as far as the industry is concerned, if there is an investment and large investment is required, how can we do it without some kind of an assurance? Today we are normal procedures of tendering, etc., and L1. So we are getting orders, all right, But if there is an assured order kind of a situation, then we will be more comfortable to act upon it, and more comfortable to invest more and more, create new facilities, better facilities, so that we can do the work in time. So there is also a requirement of research, development, testing, and infrastructure building up for testing and trials, etc. So this is also, some funding will be required for that. Manpower is another very important topic. Time and again, we will have facilities if there, no skilled manpower is available, and the skilled manpower retention is also very difficult. Plus, the manpower has to be rejuvenated with the new requirements, etc. So therefore, repeated upgradation courses, etc. we will have to plan it and implement them. So this is also a requirement. The government concessions, unfortunately, nuclear power is not like a renewable energy. Government is offering many concessions to the renewable energy. So such kind of concessions, if the nuclear power also gets it, then it will be more cheaper and affordable. So therefore, if these are the issues in front of us, we need to address them properly. Without addressing them, we will not be able to answer to the public, answer to the people from whom we are getting finances and who are our end users. So what we need to do is possibly, these are all advisory things. I'm just sharing my experiences and what other countries are doing it. So I have studied many countries' approach to SMRs and approach to new projects, etc. And from that particular study, only I am narrating these particular things. So this is only in the form of advisory. So to generate the confidence in the minds of the stakeholders and to enable them to commit their resources to SMR, the Government of India must undertake a systematic study of all issues related to the setting of SMRs and publish a formal SMR policy document. Like we have published the green energy or the green hydrogen policy. So some of the countries, they have actually set up working groups to each one of these particular topics. And these working groups are consisting of experts in their own domain, as well as a representative from the government, representative from the industry and other stakeholders, so that you pitch in your opinion and try to bring out an acceptable solution so that for each of the topic. So the first and foremost is, what is our vision? Because unless that is available to people who are stakeholders, that is required to be done. Whether we want to have the PWRs or we are satisfied with the 220 megawatts PHWRs, or we want the molten salt reactors or high temperature reactors, we have to study all these things and bring it as a vision, as a national vision. Then everybody knows this is what is the vision and this is what we have to work to. So national vision is required. Then chosen SMR technology is chosen. Then Indian nuclear regulatory readiness. Of course, I am in touch with the regulatory people, and they have been making good presentation to say that we will not be the kind of holding up agency for a good progress or fast progress. Then Indian economics, finance considerations, preparedness, private funding, amendments to Atomic Energy Act, CLND and insurance. There has to be clarity and there has to be an action taken on these. Then Indian SMR, nuclear waste management. We all talked about it, it's very important. Then we got to have a roadmap because there are 100 reactors to be constructed, the sites have to be decided and all that kind of stuff. So unless we have got a roadmap, then heavy industry preparedness, additional infrastructure, investment requirements. These, I think, every individual industry will take up and do their own internal workup. Then business potential or organizational structure. Now this is also a very important thing, because we are not talking about 1-2 reactors, we are not talking about 1-2 sites, etc. And unless there is a focused organization like Bhavini for say fast breeder reactors. So got to have a specific organization, a group who will undertake a specified work. So this is important. So these kind of documents, they must be officially available as an approved documents from the government of India, and that is what is the visibility. Today morning people talked about, Ramani talked about the visibility, and they have brought the visibility in their country. So much of good visibility that everybody knows that this is the direction which the country is going, this is the direction which people have to work. So that is the important issue. So selection of executable design, I talked about it. So what we need is actually somebody has to own this. Probably in our case it will be BRC. So set up a central agency. This is again an experience of mine in the nuclear reactor program, ETV program. So this is SMR design agency is required, and that will bring an expertise to work out the specialist inputs, integrate them and prepare the workable design for the interpower plant. So this has to come up to the working level drawings, issuable drawings for the tenders. It's not just point of that the sketches, sketch design is only available, detailed engineering is, because these are time taking. These are, sometimes it takes about 10 years to have a design which is executable. So we have to consider that. Then set up an independent SMR design safety review committee. This is also in our program, we had a safety review committee, and they worked along with us. And therefore there are defined responsibilities and defined group who will continue to be in parallel work with the SMR program, and that is what is required. Then after that, we got to have a first of kind demonstration reactor. Because that is only going to bring in a confidence of operating of this particular plant, and also from the experience which we will gain, we will then in a position to say this is more economic, this is better for farming and all that kind of things, and therefore we will go to the standardization from there. So from the 2-3 reactors operating, then we will be able to define we got to have some more number of reactors, and therefore standardization can be brought in. So we have to spend some money to generate a confidence in a particular design. The industry be involved in the choice of this. All these activities, industry must be involved, so that they, whatever they want to say or whatever their projections and then their investments, etc., they can plan it. So possible designs, there are many options, there are about 80 options, but we have to possibly do this particular exercise to bring in 1 or 2 designs which are executable. Then execution. Now this is also important because it's a large volume of work. This is the existing organization, NPCIL is already overloaded, and therefore this particular load, and there has to be a qualified people, good people, etc. So I think we got to have organization something like Bhavini only to deal with SMR if we are talking about or thinking about hundreds of reactors to be made like this. So SMR Power Nigam Limited kind of an organization, and there has to be some funds given to them so that first of a kind of reactor they can execute and demonstrate that it is possible to create the SMRs. This I have talked about it. Government incentives, I have talked about it. So we got to have these kind of things done for a SMR. Selection of sites, we keep on talking about the coal base. Power stations will be, out of, use, and therefore those sites can be removed. There are SMRs, people are offering it with the exclusion zone about 500 and less. But these are to be examined and things like that. So, but there is also input saying that, okay, coal-fired thermal stations will be rejuvenated and new systems will be done up. So whatever we are talking today, that has to be now confirmed. How many really sites and where are these sites, that has to be confirmed. Some people say in the same reactor plant areas, you will have more space, and therefore exclusion zone also will be reduced, and therefore you can set up more cluster of SMRs there. All this is only talk at the moment. So there has to be a document to say that, okay, these are the 100 sites where 220 megawatts of reactors will be set up. These are the 100 sites for, say, SMRs and things like that, So, and it takes time, because getting site approved by ARB also there is a chain of activity, and chain of, time spent on that is quite a bit. Manpower development is a very important. As Anil has just now said, the skilled manpower is very difficult. And skilled manpower takes time. To be an experienced operator, it takes time. And to retain such kind of a operator in the system and in the organization without the jobs, without the kind of a business, is very difficult. They run away, or the industry, if the business is not there, we have seen many times that we drop all jobs on the nuclear and we go to something else, chemical industry and some other equipment manufacturing, things like that. So if we are thinking of big 250 gigawatts of power, the continuity of business and the formal training, like NPCL has got 3-4 training centers, Rawatbata and in Chennai, etc. We need to set up such kind of training centers, and the upgradation of manpower is required to be done up. Now, there is also a requirement of various codes and standards, because if currently also we are facing a requirement of the RCCM code and Russian codes apart from the ASME codes. So that training also is required. People have to be experienced in that. So it is a time-taking exercise, and it is financially also expensive. So some estimates I have done it. So quite a large number of jobs will be available through this particular exercise. Now, industry preparedness. The track record of the industry, Indian industry, is very good. We have been contributing right from the 1960s, when the first of reactor was being built, and that time when the CANDU reactors were done up, we had hardly any knowledge about it, and we could increase our knowledge and meet the technical requirements, and we have been growing with the 220 megawatts to 540 megawatts, 700 megawatts, also contribution to the PWRs and things like that. So, while doing this particular thing, we need to invest. We need to invest to upgrade our infrastructure, as well as somewhere we need test facilities, somewhere we need NDT facilities and things like that, manpower training. So all this investment is required to be done. And since a large number of plants are being set up, so industry has to learn a lot, because various codes and standards, various types of reactors are going to be, and the technologies will be different. So we have to have a lot of learning to be done up to implement what is, designers want us to do it. Modular construction also, this also will require different facilities, and also once you do create a module, then it has to be tested also. So we will have to create some testing facilities also. So we are prepared to do all this. Therefore, following need to be addressed. So what is important is stakeholders, which I have narrated here. There has to be an approved document from the Government of India or from DAE. This is the direction, this is what we are planning to do in coming 10 years, 20 years, etc. So that kind of a roadmap. So that has to be available, so that people exactly know, okay, what is going to be done up and where they would like to participate and invest. So developmental aspects of the work need to be addressed, costed and compensated reasonably. The standardization of the design processes and procedures will help in minimizing the time frames of the construction. The investments by the industry in view of infrastructure and facilities will call for certain minimum assured continuous business and reasonable cash flow. The creation of the infrastructure takes time, and so necessary advance action need to be taken up as early as possible. there will be certain critical materials that need to be procured, and it is better that it is centrally procured and issued as a free issue materials, because then it will be centrally controlled, quality assurance will be maintained, and the investment by the industry will be less in this particular case. So it is easier and better. So industry certainly will participate in these activities of nation building and zero carbon emission. So from the industry point of view, I think everybody is assured that yes, industry will participate fully and quickly. So in conclusion, I would like to say that target set by Government of India for net zero carbon emission by 2070, this is an ambitious target, but necessary for climate control and minimizing the natural disasters taking place now. There will be a need to have about 15 gigawatts of power generation by nuclear plants. Government of India has planned for 700 megawatts, 1650, 220, and the fast breeder reactors, uranium-233 reactors, SMRs, is well thought out and feasible for execution. SMR designs being new, a proper study of various aspects of the SMRs program need to be undertaken, and Government of India policy published amendments to the existing Atomic Energy Act undertaken before launching the program. This has to be done before. You cannot do the course correction, that will be very expensive, time consuming. So SMR technologies will be diverse, new to the designers, regulators, industry, financing agencies, quality assurance, materials, etc. So new infrastructure and facilities will be required to enable modularization, assembly in workshops, and transportation to the sites. For smooth execution, Government of India needs to set up the following: SMR Design Agency, SMR Design Safety Review Committee, and SMR Power Nigam Limited, that is SPNL. So in conclusion, the stakeholders need to be taken into confidence and their concerns are to be addressed satisfactorily. Their participation, contribution to the developing program will help the proper and full-scale deployment of the program. With government funding and the first-of-kind SMR to be set up for every new design and operated to gain the experience, so that standardization of the reactors could be done and used for the further production to reduce the cost and time frames. The cost effectiveness and the public acceptance need to be assured. The overall built plan of the entire program needs to be prepared and implemented. The financial provisions must be made suitably, maybe with the participation private funds and FDI. So this is all about the SMR part of it. Now, what contribution, role of Walchandnagar industries in the nuclear power program? So in short, the critical reactor island components are indicated here. And design, engineering, production, we have capability. We have already done the Morata heat exchanger design by ourselves and supplied to 8 heat exchangers, and they are all operating now. So this is proven design. Similarly, critical reactor equipment and integration of complete reactor plant for the nuclear submarine, we have done it. Piping for the sodium cooling primary system of 500 megawatts fast breeder reactor Kalpakam, we have done it. And other than nuclear, per se nuclear, heavy water storage tanks, high pressure tanks, feed water, surface condenser, main and auxiliary air lock system, etc. Some pictures and details I will just show you. So design, engineering, machining, testing, fabrication, logistic transportation arrangements like this manipulator, and site fabrication and commissioning, all these works we have done. Equipment supplied for the research reactor. This is the list of equipment which we have supplied right from 83 onwards. This is then for 200 and 500 megawatts of reactors, we have supplied these equipment. More details I can give you to concerned people. 200 ye ho gaya. Then 700 megawatts we have doing this particular works now currently. So, association with Bhavini and NPCIL, these are a few things which we have shown. Then for BARC, that is for mobile reactors, we have supplied this equipment. This is a high pressure vessel, 1 meter diameter, is about 40 millimeter thick plate. From the plate we have made this particular thing, and this has been tested to 250 bars pressure. Similarly, another 9 meter diameter spherical vessel we have made. And for the Bhavini, these are the components we have supplied. These are the equipment we have supplied. This is a primary cooling piping system. So this is what we have done, and we are prepared to do more things. Thank you.